Many thanks for even for organizing such a wonderful conference. So I think this conference is quite catch up with the stream of the artificial intelligence now. We hope that we can have such a conference every year in the future. So today I'm going to give you a talk on forecasting exchange rate with a machine learning approach. So this is quite a new project for us. So it's still a project in progress. So if you have any questions or feedbacks, please feel free to let us know. And this is also one of the few papers that I target for finance journal, not an income journal. So let me first give you an introduction about this project. So there's a famous puzzle in the international finance literature called the Nielsen-Rogoff puzzle. So this puzzle says, okay, although the theoretical model predicts that there should be a close relationship between exchange rate and macro variables, we cannot find any data. Generally, the macro variables can hardly predict the exchange rate. It can not perform better than the simple random walk process. Okay, then we have a reflection on this puzzle. We consider that the reason that the traditional macro model cannot predict the exchange rate is that the model could be too simple and the information, the data could be too limited. So first of all, those models are mostly linear and will limit the number of macro variables. And the second is most of the macro variables are released with low frequencies, and they are with a measurement error, so they suffer from delayed release and data revision. So in this paper, we propose using the firm characteristics to predict exchange rate. So on this page, I want to explain the motivation why we think the machine learning method and the firm characteristics could help. On the one hand, the machine learning approach could allow for nonlinearity, and then the firm financial characteristics that do not suffer from data revision. And secondly is through the consideration of the theoretical literature in the exchange rate. In recent years, the literature argues that exchange rate can be determined or affected by expectation and expectation bias. Okay, it's also affected by risk and the risk perception about the investors, and then the liquidity and the collateral constraints of the firms and the banks can also matter. And finally, the firm level productivity can also matter. Okay, then our rationale is we consider that the firm characteristics and firm decisions may incorporate those information much better than those in the officially released macro variables. So that gives us a motivation for using firm characteristics in predicting exchange rate. And then what do we do? So I kind of want to summarize everything in one page. So this is an easy page. So what we do is we try to forecast the exchange rate for 13 currencies in short term. So our forecast horizon is either like a 1 month or 6 months. So it's a short horizon forecasting. And we try to forecast these exchange rate returns with 153 firm financial characteristics using 3 different machine learning methods. We try to answer the following research questions. First, do machine learning approach with a firm level with firm characteristic forecast better than simple random walk benchmark? If it does, of these 3 methods, which one performs the best? And the second is of these 153 firm characteristics, what kind of firm characteristics have predictive power for exchange rate? And the third is if our forecast is good, does our forecast has any economical value? Can we construct a portfolio that portfolio returns can be better than those predicted by the random walk? And finally, we also want to connect this to the exchange rate accumulation literature. In the literature, the researchers used to usually decompose the exchange rate into 3 components: the interest rate differential, the risk premium, and the convenience yields. And we also want to explore which component of these three components can be predicted by the firm level, firm characteristics. So what we find is first, so I didn't write the finding here, but the main finding is to answer the first question, yes, it does. The machine learning method performs better than the random walk approach. In general, the random forest works the best in our exercise. But for example, a few currencies, the support vector machines performs better than random forest. I think in 3 of the currencies, the SVM works better. And for the which firm characteristics has predictive power, our answer to this question is it differs from currency to currency. So we will highlight more details here. And then number 3 is we use 2 measures to evaluate so we construct a portfolio by doing that constraint optimization problem. And then we find that if we evaluate through Sharpe ratio, the machine learning method should give you a higher Sharpe ratio for the constructed portfolio. And then we also evaluate the cumulative return from in the foreign exchange investment. We find that if you believe our model, then you can make 30% to 40% more than those predicted by the random walk. And for the last question is since our project is in progress, I do not have an answer on the last question right now at this moment, but this is some future work we will work on. Okay. I will briefly talk about the literature review to highlight the contribution of this paper. So in the machine learning nowadays have been widely used in empirical asset pricing. So there is a nice review of financial studies paper by Wu et al., which nicely summarizes the literature. And however, the machine learning method is mostly used to forecast the bonds return, stock return. Not many papers use this approach to forecast the exchange rate. And when you go to exchange rate forecasting literature, there are at least 3 methods now. The first is the traditional approach. You just use regression models and try to include those which you think are important. So Rossi 2013 gives a nice literature review, and recently Charles Engel and Steve Wu has a very new paper which falls into this literature. And then those models mostly motivated by quantitative theory. And in the finance side, followed by a series of papers by Handel Lustig, they just try to use the factor models to predict the exchange rate. So this is basically, but the factor they consider here are mostly currency characteristics, not firm characteristics. Okay, and very recently, Filippo et al. 2023 has a paper. So this paper, I have invited one of the authors to present this paper in our department seminar series early this semester. So that paper is trying to use macro variables to predict the exchange rate. So they just use a large number of macro variables and the machine learning method to forecast the exchange rate. And a very recent paper which was just released last month, there is a Cui and Yong Miaofeng and Mei Jinhong. That paper is about trying to use the stock returns to forecast the exchange rate. But they only use the stock return, they didn't use those firm characteristics. So we think our paper bridge the gap in the literature. It's in this traditional empirical asset pricing about stock return, they also go through this process. They also initially they did the traditional approach and then they do the factor model, and then now you can see that it's very popular that they do the machine learning approach. So the exchange rate forecasting is going through the process right now as well, and I think we are standing in the frontier of the literature right now. Okay. Okay, now let me get to the details. Okay, so the data our sample period are from the January 2025 to December 2020, and we have 13 include 13 currencies. So here we just follow the literature, define this return as the log growth of the log exchange rate, and this is going to be our dependent variable and the target variable. And our independent variables are those 153 characteristics from which was originally from CompuStat, but it's reorganized by Jensen 2023 Journal of Finance paper. And so here, it listed, we almost have close, almost 20,000 firms, but it's not evenly distributed across the countries. The way we do it is we do it the country by country forecast. Basically, when we forecast the US dollar exchange rate, we only use the firm in the US. When we try to talk about the exchange rate for South Korea, we only use the firms in South Korea. But even though the information we have here is much larger, and the number of the variables here is much larger than the traditional macro variables. So basically, if you want to summarize the predictive equation, it's just this return depends on the characteristics and the epsilon. So it's just we do a ruling window forecast. It's just the different machine learning approach will give you different functional forms, right? So the ruling window, what we do is if we do 1 month ahead forecast, we just use the past year's firm level firm characteristics, and then so basically this is our training set is the past year's firm characteristics, and then we try to forecast what happens in the next month. Okay, so this is a picture showing our ruling window forecast. And then we use 3 methods. So because of time reason, I won't have time to get to the technical details. The first method is the elastic net. So elastic net is a kind of, you can consider it as a combination of lasso and ridge. So it has both L1 and L2 regularization. And here we can fine tune the lambda and the rho parameter so that to get the optimal forecast we have. And then the second method is the random walk forest. So we can use those regression trees to achieve optimal prediction. So in our project for each country, we use kind of 300 regression trees, and each tree can have 13 layers, achieved to forecast the exchange rate. And then finally, we have this support vector machines. Basically, those firm characteristics can be hardly separate in the no dimension space. So the support vector machine just mapping the low dimension, the observations in the low dimension space to a higher dimension space, and to probably separate it and predict the exchange rate. Okay, so now let's look at the result. So our first target is to evaluate the predictive accuracy. So we use 2 measures. So one is the Campbell assumptions, other sample R squared. What is in the numerator here? R hat is this R without any superscript is the actual data. R hat is those predicted by our model. And in the denominator, this R bar is just the average value of the growth rate of exchange rate. As a result, basically the denominator actually evaluates the forecast the performance for the random walk process, and the numerator is our forecast, our prediction accuracy. So basically, if this R square OS is a positive, we consider that our model is better than the random walk. But here, it's not a test, it's just compared against the 0. And then in the second one is the so-called Clark and West mean square forecast error adjusting test. So this will give us a test statistics and let us know whether our method is significantly better than random walk at a different significance level. Well, so we do have tables to show those tables to show the significance and different things. But here I just want to summarize this information in 1 page. So first, what we find is if we focus on 1 month forecast horizon, the machine learning method predicts better than the random walk, except for 3 currencies, which are the Australian dollar, Canadian dollar, and the Sweden krona. Okay, and then but if you look at the 6 month horizon, the machine learning methods just beats the random walk for all the currencies. If you compare among those machine learning methods, the random walk generally perform no worse than the other methods, except for these 3 currencies where the support vector machines better, which are the Switzerland francs, South Korea won, and Russian ruble. Okay. So this is about the prediction accuracy. And the second thing is we are trying to think about, okay, we are having so many like characteristics. So which characteristics is important? There's a typo on the title. The important is misspelled. So basically we employ the population importance method proposed by Altman et al. 2010 to measure the importance. And then since we have so many characteristics, so we categorize them into 6 groups according to Ho et al. 2020 AIIFC paper. So there are 6 categories, which are the momentum, value, investment, profitability, intangible, and trading frictions. And then we present in the bar graph just the importance of the top 20 corporate characteristics. It's going to be like something like this. So you can have like this. This is Australian dollar. So each panel is a currency, and then you have these different bars are the characteristics. And then we can put different color sports into different categories. It's difficult to see the details in the slide, so I summarize the information here. So basically, I want to let's think about it for this Australian dollar. If there, so we can see that these purple bars is the dominant factor, right? So as a result, I define the dominant characteristics for the prediction are those with no less than 6 of the characteristics in this category. It's important for the key prediction. Basically, what we find is okay. So there are some characteristics which are never dominant for exchange rate prediction. There are value trading frictions, and there are some countries there's no dominant factor. Those currencies there is no dominant characteristics. And for the others, you can find for the US dollar, the investment characteristics is important. These characteristics is important for US dollar and South Korea currency. Also, South African currency. Okay, so this is the dominant characteristics. Similarly, you can evaluate this. I define another thing called important characteristics. Basically, I lower the bar. I am not thinking about this bar has to have 6 bars in the same graph, in the same color. I just lower the bar to 4. I consider it as important. And then if I lower the bar to important, there is no currency which has no important characteristics. So there are only 6 categories now. What we find is the investment characteristics seems to be important for most of the currencies, like for the 10 currencies. And the value characteristic is only important for 3 of the currencies. That's the second dimension we evaluate. The third dimension is we look at what are the unimportant characteristics. For example, for this bar graph, there is a color with with no. Let me find an example. Suppose this bar only have 1 or no bars in this color. We consider it as unimportant. And then what we find is for this unimportant one, we find that the value characteristics is not important for Australian dollar, Indian rupee, and South African currency. But the results is quite heterogeneous. It's a different country with different unimportant characteristics. So to sum up here, there is quite a heterogeneity among currencies. And then why there existed such important heterogeneity? This is something we have to explore further. Okay. Now finally, you say, okay, now you have evaluated whether the machine learning can help in terms of statistical tests. You also talk about which characteristics is important. Then is that useful for our investment? Because this is artificial intelligence in finance, or artificial intelligence in statistics, right? So we want to see, okay, can we construct a portfolio which can help you make money? Okay, so here we just define the economical, we just define the exact return of a country. You think about, since our benchmark currency here is euro, so you just think about you long a country's currency and then short another country's, and short the euros, whether you are going to earn excess returns. So these I are interest rate, these are actually correspond to the exchange rate growth. Okay. And then we can solve this maximization problem to solve the portfolio weights for each currency. So basically, we just combine our forecast of the different currencies. Yeah, we have to decide on a weight for that. That is the way we construct the portfolio. So what we find is if you look at this Sharpe ratio, if you do the random walk, use random walk to forecast, your Sharpe ratio is around 1.4. But if you like do the first three columns are different machine learning method, you can get to around 1.8 or even 1.9. Okay. And another thing is, let's just try to see. Okay, suppose you have $100, you like invest in 2007, and then you just keeps like working on the portfolio construction with different forecasting method. It seems that if you stick with the random walk assumption, you will get less cumulative return than if you do the machine learning method. And then if you do the machine learning method, the three methods will give you very similar returns. The difference among the three machine learning methods is quite insignificant. So that is what we get here. And finally, I think I'm quite ahead of time. That's good because usually I'm running out of time. So the conclusion is, well, in this paper, we avoid the traditional way to forecast the exchange rate with macro variables. Instead, we focus on exploring whether the firm characteristics can help predict the exchange rate. So our result is we find that the machine learning method do have additional power in forecasting the exchange rate, but there are still a couple of directions for our future work. So the first of all is we want to shed some light on the theoretical studies. For example, in the theoretical studies, people think that the exchange rate we can have. So since I have time, I can talk a little bit more. So, so basically, for all the asset prices, is the discount value of your future cash flows, right? So for the exchange rate, that's about the currency investment. Your cash flow is the interest rate differential. Then, according to the UIP equation, then the interest rate differential will explain the exchange rate growth. But there are two other things that you also have to consider. One is the risk. Obviously, the US asset is less risky than the currency of a country in a war, right? So the second is the risk premium. And then the third is recent literature highlights the importance of, which is people call it convenience yield. Because the US dollar is a different, is a special currency, it's the world currency. Then sometimes you hold US assets not for risk concern, not for income concern. It's because it's safe. It's because the US currency can be used as sometimes you can use it as a collateral to borrow money. So basically, US assets is more liquid than the foreign assets. So that convenience yield try to show the liquidity premium, and that liquidity premium could be high when the borrowing constraint is binding. Right. Then, the next question we are trying to explore is, okay, whether this firm level characteristics, this financial data can reflect the risk, interest rate differential, or convenience yield. So that is the question we are going to explore next. Another is here we use in our initial stage we use euro as the benchmark currency, and now we also want to see, okay, we use US dollar as the benchmark currency, what the results will change. And number three is, okay, now we have successfully predicted the exchange rate, but can the predicted exchange rate be helpful in explaining the behavior of other macro variables? So those three lines are what we are working on right now, and I hope we can get good results. Thank you. Any questions? Go ahead.
Yeah, that's right. I didn't quite see. So for the firm level feature measurement,
Right.
what sort of features were you using for that? You had them grouped under momentum, kind of stuff like that,
Right.
or was that you would group the firm level characteristics under those things, or
So when we predict the when we do the forecasting, we didn't categorize it. We used the 153 characteristics.
features? Yeah.
Right, but it's just when we try to evaluate the importance of the characteristic, it's difficult to see the pattern if you have the right in the original form. We categorize it into 6 groups according to an early paper.
And do you list it in your own paper? Do you list what those features are?
Yes.
Okay.
Yes.
Thank you.
Another question?
Menu. So the firm characteristics are usually even more lag than macro variables, right? So macro variables you usually get, depending on the variable, of course, but you might take it, it takes 1 month, right, to get inflation reading, something like that. Firm characteristics, it can take, depending on whether you're looking at annual or quarterly financial statement data, it can take 60 days, 70 days to get it. Why do you think that you get better accuracy with firm characteristics that are even less timely than macro variables?
Right. So I have 3 thoughts. So probably my colleague is better in answering this question, but let me try my best. So first, you're right. So they could have quarterly report or something like that. But here we consider many firms. They are not releasing the information at the same time. Right, you have 10,000 firms. They are not releasing it at the same time, so you have information updated almost every day. Okay. The second reason is my second concern is the macro variables. Although they have a release schedule, like GDP, they have a release schedule. So, but sometimes they revise the data. So it will not be the first release actually reflect the current state of the economy. And then my third concern is what you are talking about is exhaustive, right? That's my motivation. And then kind of when you want to prove whether this is has additional information, then we have to look at the forecast it exposed. It seems that it exposed that validate the exhaustive motivation. That is what my thoughts on this. Other questions?
Frank, what did you find in terms of predictions from a point of view of time interval? Do you find short term is better or versus longer term? So I think that you did 1 month and 6 months. Right. What is your kind of, what are you finding in the data? Machine learning is helping in short term or longer term?
Oh, so I think I don't know about finance, because finance you use high frequency data, even you a month, 6 months is kind of like a long time span. But for macro, people think both 1 month and 6 months are short term.
Okay.
Right. So yeah, we think both of them are short term. It's just in exposed, if you see the test statistics, it seems that 6 months forecast is better than 1 month. Yeah.